Good day, everyone. Welcome back. This is the second lesson in Math 10C in Unit 1, which is dealing with measurement. And this is a continuation of the first lesson. This is part 2 of section 1.1 of your textbook, dealing with the metric system and how it's used in measurement. We're going to be doing a couple of things today in this lesson. One is we're going to be applying the circumference formula. And I have just something I want to say about that before we go on. And I think it's important you understand why we do what we do in these lessons. We are learning about the circumference formula not because there's anything particularly important or interesting about circumference. We're learning about the circumference formula because we need to get better and better at working with formulas. So I could have built a lesson using an area formula here, or I could have built a lesson using a perimeter formula for rectangles in this lesson. The important point is we're learning about how to use a formula. And then the second thing we're going to be doing here is solving problems that involve scale. So to begin with, I'm giving you the formula for the circumference of a circle. I want to write each of these down and just talk about them briefly. One of the formulas says C is equal to 2 pi r. This formula is on your formula sheet that I've provided you. That simply means that the circumference of a circle, which is the distance all the way around the outside of the circle, is equal to 2 multiplied by pi multiplied by r. Now, if you want, you could take that 2 multiplied by pi multiplied by r, and you can switch the orders of these things. I could say pi multiplied by 2 multiplied by r. The order in which you multiply things together doesn't change the result. If you take 2 times 3 times 4, I'll just write that down so you can see what I'm talking about. If you were to take 2 multiplied by 3 multiplied by 4, and somebody else were to take 2 multiplied by 4 multiplied by 3, the first person is going to multiply the 2 and the 3 together to get 6, and then they're going to multiply 6 by 4, and that will give them 24. So they will get 24 here. What will the second person do? Well, the second person can take 2 times 4 to get 8, and they're going to multiply that 8 by the 3, and surprise, surprise, they're still going to get 24. So the order in which multiplication happens doesn't change the result. Again, I'm teaching you something that's not particularly important to this lesson, but it will be important in other areas in math. How is this even useful, though, in this lesson? Well, all I did was I switched the order of the 2 and the pi and the r, and now what I can do is recognize that 2 times the radius of a circle is the diameter of the circle. That is basic circle geometry that you learn about junior high, maybe even you talk about it even in elementary school. So it's very easy to demonstrate that 2 times pi times the radius is the same as pi times the diameter. Well, that's your other formula. It says circumference equals pi times the diameter. Let's take a look at the first question here, A, which is really child's play. It says the radius of the Earth is 6,370 kilometers. What's the circumference of the Earth? Now, even after a lesson and a little bit, I think you understand my approach to teaching is to prepare you for what's around the corner. I want people to solve this kind of problem in a very specific way. You write down the formula, and then below that, you show all of the substitutions of numbers that go in there. What you do not want to do is go C equals 2 pi r and then go equals and work left to right. That is a fatal mistake that is really going to hurt you when it comes to algebra. We work line by line, top to bottom. So now what I do is I put in well, 2 is just 2. Pi is just pi. We'll get to how we access pi on the calculator in a second, times the radius, which is 6,370 kilometers. Now, because the radius is in kilometers, we're going to get a circumference in kilometers. When I write a number like 6,370 in brackets beside something, I'm simply saying we're going to multiply them together. Now, how is it we do this on the calculator? Well, I'm going to be using my graphing calculator to demonstrate this. So if I grab my graphing calculator, the first thing to note is we need to understand where give me 1 second. We need to understand where the pi is on our calculator. And on my calculator, it is right there. It might be a little faint in the video, but it's right there. It's the blue function that's the second function of that little thing that looks like a roof. And we'll get to later in the course what that little thing that looks like a roof is. So if I want to access that pi on my calculator, the first thing I have to do is hit the second key, and then I can hit this key and pi will come up on the calculator. So going back now to this problem and accessing my calculator, just to show you accessing pi, if I were to turn my calculator on and go second and hit that little roof, pi pops up on the screen. And we don't need to worry about it, but if I hit equals, there it is, there's pi. And the decimals go on forever, and we'll have a good conversation about that in the next unit. But if I want to just multiply 2 times pi times the radius, I can take 2 times pi, so that's second roof, times 6,370. And this is the answer to my question. The circumference of the Earth is approximately 40,023 kilometers. Well, we'll round it to 40,024 kilometers. And as I said, this question is very simple. It's like taking candy from a baby. All you're doing is putting the numbers into the formula. Let's take a look at the next question, which tells you that the circumference of the eyeball of a giant squid was measured to be 85 centimeters, and it asks for the radius. Well, if you're trying to find the radius and you know the circumference, let me just write this out so you can see my thinking. The circumference is 85 centimeters, and we are asked to find the radius. Well, the strategy we use in math and science is we look at this itemized list of things we know and want to know, and we find a formula that has those items in it. And the formula is the same one, C equals 2 pi r. Now, this also is a simple question, but there are little bumps in the road that you may encounter. So we put in the numbers. We have 85 equals 2 times pi times the radius. And what we are trying to determine is this. So I'm going to take you back to grade 7, grade 8, grade 9 math and talk about solving very basic equations. If I gave you the equation 120 equals 20 multiplied by x, in junior high, you're kind of taught to reason out what the number is. You're kind of taught what number multiplied by 20 gives you 120. So the goal in this equation is for you to determine that. And with a little bit of thought, you can see that it's 6. Okay? And I'm going to come back to that in a second. The problem with just trying to figure that kind of thing out is what if the equation is 74.8 equals 1.3, I'll use y this time, and this time you're trying to find y. Well, I'll tell you what, your brain is not wired, and neither is mine, to be able to figure out what number times 1.3 gives you 74.8. And that means we have to come up with a better way of doing things. We have to come up with what I call a more formal approach. And when we're looking at solving the equation that I have in green, what you can do is say that since 20 is being multiplied by x, if we want to isolate x, we got to get rid of the 20. Well, how do you get rid of multiplication? The answer is you do the opposite, which is to divide. And if you divide one side of this equation by 20, you must divide the other side by 20. And what good does that do? Well, what it does is these 20s cancel, and you're left with x equals, and you can figure out what 120 divided by 20 is. It's 6. And if you don't know that it's 6, this is the whole point, I suppose, you take your calculator and you go 120 divided by 20. Oh, it's 6. So what that means is that in our blue equation, if you want to get y by itself, then you're going to have to divide both sides by 1.3. You always divide by what's in front of the unknown that you're trying to solve for. Of course, what happens here is those cancel, and you are left with y is equal to whatever 74.8 divided by 1.3 is. $57.5 approximately. And I know for a fact that most people watching this, I've forgotten what I said, 57.5. 57.5. I know that most people watching this will say, well, that's so simple. We don't need a formal approach to it. But things will get more difficult as we progress through the course. So what happens here? I need to take both sides of this equation and divide them by 2 pi. So what I'm going to get is r is equal to 85 over 2 pi. Because the 2 pi's cancel. Now here's the trick, and if you like, you can pause the video here, grab your calculator, figure out what 85 divided by 2 pi is. Okay? So actually I want you to do that. Pause the video, take 85 divided by 2 pi on your calculator, and don't write it down yet, just leave it on your calculator so you can see it, and then resume the video. Well, I suspect that many people, maybe everybody, and I know this from experience, would have entered 85 divided by 2. Let me get that cleaned up. If I can get it. Come on, there we go. I suspect that people would have gone 85 divided by 2 pi. And I will tell you right now that this is the wrong answer. The answer is not 133.5. And I can demonstrate to you that it's not, because if I take 2 times pi, let's just see what 2 times pi is. It's a little bit more than 6. And if I take 85 divided by that answer, I'm going to explain to you how you can use your calculator a little more efficiently when we are with each other together one-on-one. But in the meantime, I'm just going to type 6.283185307. If I take 85 divided by that number, I sure as shootin' don't get 133.5. I get 13.53 approximately. The issue is the following. So I'm teaching you how to use your calculator. If you take 85 and enter divided by 2 pi, what your calculator is seeing is this. It's seeing 85, and then it's going to divide that by 2. But between the 2 and the pi is a multiplication sign, so it's going to multiply that by pi. And that's not what we want. That is not going to give us the answer. What we want is the following. We want 85 divided by, in brackets, 2 times pi. And that will give us the right answer. So going back to the actual question, here is the correct answer, 13.53. One final note about this. So R is equal to 13.53. If you take a look at what this is saying, let me show you how I was taught to use a calculator. And over the years, I've discovered that many of my students prefer this method as well. To get R by itself, I have to take 85 and I have to divide by 2. And I also have to divide by pi. I have to divide by 2 and I have to divide by pi because they are both under the 85, and that will give you the right answer as well. All right, let's move on to the next example. A circular garden is shaded in the diagram, and it has a radius of 7 meters. There's a sidewalk that is 2.5 meters in width all the way around. One child walks around the garden using the sidewalk, but one walks on the inside and one walks on the outside. A little bit of a typing mistake there. But what this question is saying is, one child walks all the way around and they start at this position and they walk all the way around. They start walking and they return to that position. The other child starts here and they walk around and they return to that position. Clearly, the child on the outside walks further. Now, what is the question? The question is, how much further does the second child walk? Well, the radius of this garden, the distance from the center to the actual garden, that is 7 meters. So that's the radius of the small circle. Well, what that means is we can find the circumference of the small circle. That is easy. The circumference is equal to 2 times pi times r. So for the small circle, the circumference will be 2 times pi times 7. Now we can calculate that. As I said, it's pretty easy. 2 pi times 7. The child that walks around the smaller circle walks about 44 meters, 43.98 meters. Now, what about the child that walks around the larger one? Well, we still have to use the formula C equals 2 pi r, but this time the radius is different. The radius of the larger circle is equal to the radius of the smaller circle plus 2.5. You're told that this little distance here is 2.5 meters. If that's 2.5 meters, then this entire distance, which is the radius of the larger circle, would be 7 plus 2.5. So 7 plus 2.5, well, that's easy. Gives us 9.5 meters. So the circumference of the larger circle will be 2 times pi times 9.5. Let's pull out the trusty calculator. 2 pi times 9.5 gives me 59.69 meters. The question was, how much further does the second child walk? Well, now that you know these two distances, all you have to do is subtract them. We can take the 59.69 and subtract 43.98. And at this point in the course, we're just learning about math. I don't care about decimals or accuracy. So let's take that. If you just hit the minus key, that's what will pop up. And then we can type 43.98. The answer to the question is about 15.7 meters. Let's look at the next example. We have a large wooden barrel that Kyla has bought, and she's cut it in half to make a planter. She's going to put a metal band around the top of the planter, and that's going to hold the thing together. You're told the radius of the top is 0.6 meters. You're told the bottom band is 1 meter shorter than the top band, and you're asked for the diameter of the bottom. So here's a picture of the planter. What do we know about the top? I believe, and I'm just going to go back and check, but I believe the top of the planter has a radius of 0.6 meters. Just double check. Yep. You're told the band at the bottom is 1 meter shorter than the band at the top. Well, the band around the barrel is the circumference. And by the way, anything I'm writing up here is dealing with the top, and anything I'm writing here is dealing with the bottom. The circumference of the bottom is the circumference of the top minus minus 1 meter. That's what you're told. You're told that the band around the bottom is 1 meter less than the band around the top. Well, what we can do is find the circumference of the top, and I'm just going to summarize that by putting it over here. The circumference of the top is 2 pi r. Let's see what that works out to. 2 times pi times 0.6 gives me about 3.77. That means the circumference of the bottom is that 3.77 meters minus the 1 meter. What does that give us for the circumference of the bottom? Well, 3.77 minus 1 is 2.77. If you feel the need to use a calculator because you're unsure at times, that's fine. So what have we done here? We've used the radius that was given to us for the top. We've used that to calculate the circumference of the top. We've used the circumference of the top to find the circumference of the bottom, and we were asked for, I think, the diameter of the bottom. Well, that's easy because we have a formula that says circumference equals pi times the diameter. So we can put 2.77 in for the circumference and solve this equation for the diameter. You're going to find the diameter by dividing both sides by pi. and getting the diameter equals whatever. I'm going to just rewrite that. That just doesn't look right. It looked like an 11. Whatever 2.77 divided by pi is, that will be the diameter of the bottom. I'm just going to take this number on my calculator and subtract 1. There's the circumference of the bottom, and then I'm going to divide it by pi. So about 0.88 meters is the diameter of the bottom band. Next example. In the picture shown, the height of the person is 1.75 meters. Determine the height of the dinosaur. I feel the need to tell you, although I hope you know this is the case, that dinosaurs and human beings did not coexist. This is just a problem that somebody has come up with. Well, clearly, if that person is 1.75 meters tall, then the dinosaur is taller than that. How are you going to do that? Well, what you can do is measure with a ruler the height of this person. This is one way to do it. I'm going to grab a ruler. Now keep in mind that I'm grabbing a ruler I'm hoping to grab a ruler, that I am grabbing a ruler, and the ruler happens to come out like this in terms of size, which means on my smartboard with this particular tool, this person is measured to be a height of 1.3 centimeters. I don't know if you take a ruler and do it on the actual sheet of paper this is printed on, if it's going to be 1.73 centimeters. But what we're basically going to do is set up a ratio. We're going to say that 1.75 meters in the real world represents or is represented by 1.3 centimeters on paper. So this is a scale equation or ratio where the top is reality and the bottom is the scale on paper, which represents reality. And that ratio has to stay fixed. If you draw a line on this paper that is twice as long, then in reality it will represent twice the height. So all we're going to do is set up a ratio, put x for the height of the dinosaur, and for the height of the dinosaur on paper, we're simply going to take a ruler and measure the height of the dinosaur. And on mine, it's approximately 9.4 centimeters. So I can put 9.4 centimeters here. Do my cross multiplication. How does that work? The cross multiplication means that you take this top times this bottom, and that will have to equal this top times this bottom. So let's write that out. 1.75 multiplied by 9.4 equals 1.3 times x, which we can just write as 1.3x. When you are working with an equation that has numbers in it, not pi, not the symbol pi, which is a number, but that's not my point. It's best to simplify this stuff first, but you don't have to. We know that what you're going to have to do to get x by itself is to divide this side of the equation by 1.3 and this side of the equation by 1.3. And what happens is these cancel, and you're left with the answer to the question. This is going to be equal to whatever this is. And you don't have to calculate it in pieces. You can just take your calculator, take 1.75, multiply by 9.4, and divide by 1.3. You don't need to hit equals in between and then divide by 1.3. You can do it all in one shot. So we're getting an answer of 12.65. I'm just going to round it to 12.7 meters. Does that seem reasonable? Well, I think so. If you were to take a look at, we can do it in a slightly different way. If I were to take a look at the height of that person and just say that this line represents the height of that person, the question then becomes, how many of those lines will take me up to the top of the head of the dinosaur? Well, 1, 2, 3, 4, 5, 6, I'm going to say 7 and a bit. So using a little bit of common sense, if each of those lines is 1.75 meters tall, which is what it's supposed to be, if I take 7 times 1.75, I get 12.25, and looking at where that last pink line ended, it didn't quite reach the top of the head of the dinosaur. So comparing 12.25 to what we got, which was 12.7, that's pretty good. Well, there's nothing to complain about there. I think that's it. No, one last question. A map of Alaska has a scale of 1 to 4,750,000. That's how we say that. What this means is that a distance of 1 on the map, the paper measurement, is equal to this in reality. And I still think the best thing to do is to use a ratio. We can say 1 over 4,750,000 and don't forget, this is paper. This is what it represents on paper. And this number on the bottom, I shouldn't have said that. The top number is what it is on paper. What it represents in the real world is this distance. So in reality, 1 centimeter is this many centimeters. 1 centimeter on paper is that many centimeters in reality. So we can set up a ratio. Something on the map is 8.2 centimeters, and we want to find out what this number is. Well, you cross multiply. X times 1, which is x, equals 8.2 multiplied by 4,750,000. And we calculate what that is. That, of course, is going to be in centimeters. 4,750,000. That right? Yep. Times 8.2. So this is the number of centimeters that distance is. $389,500,000 centimeters. I mean, we could use a series of ratios now to get it to kilometers, but I do think there comes a time where some of these conversions should be obvious. To go from centimeters to meters, you divide by 100, so divided by 100 gives this many meters. In order for me to go from meters to kilometers, since there's 1,000 meters in a kilometer, I divide by 1,000. I mean, I could write out ratios for all this, but I don't need to. To the nearest kilometer, it's 390 kilometers is the answer to the question. And that, I believe, is the end of the lesson. So what did we do today? Well, we worked with some basic equations or formulas, and we learned some math along the way. We just built those math muscles up a little bit more by solving some of these problems. On page 16 of your text, there's 4 problems I would like you to do for practice, and on page 48, there are 2 problems. I hope that made sense, and I hope you're getting accustomed to learning in this fashion, where I'm not always in front of you. That's it. In the meantime and in between time, take care of yourselves, and I hope to see you soon. Talk to you later.